Welcome back to the deep dive. Today we're doing something completely different. We're not looking at a stack of reports or papers. We are diving deep into a single source, a professional CV, a career document that covers a full 25 years of tech evolution.
That's right. And this isn't just a list of jobs. Think of it more like an archaeological dig into, a quarter century of innovation. Our mission is to pull out the philosophy behind it all, the technical patterns, and especially that drive for continuous learning you can see all the way through.
Right, we're going to see how one person navigated everything from, embedded systems and security?
All the way up to modern cloud architecture and leading full-stack teams. It's the whole journey.
And the key thing we want you, the listener, to see is a kind of blueprint for adaptation. This shows how things that seem totally disconnected, like writing C code for network chips versus deploying Kubernetes clusters, actually feed into each other.
Exactly. They cross-pollinate. So we're going to unpack these roles, this specific expertise, to really understand what drives a resilient, high-impact technical leader over the long haul.
Okay, let's start at the very top, the present day, the most current role. Lead software engineer at the Debate Network starting June 25. This feels like a huge cultural jump from the big corporate roles we'll get to later.
It's a decisive pivot. It's a move toward product ownership, high-velocity development. They're immediately leading development for a web app, and the stack is just built for speed. You've got Node.js, UJS, Firebase.
And the crucial services like Stripe and Chime all in AWS.
Right.
Hold on a second, though. Going from a huge regulated bank like HSBC, which we'll talk about, to a fast-moving startup, that's a massive shift. How does the CV show they managed that?
It's in the focus. It's not just about coding features anymore. It's about strategy, about sustainability. Look at the duties listed. It immediately emphasizes gathering pre-launch day metrics.
Performance load and security testing.
Exactly. That's the difference between just a coder and a leader. The leader is already planning for the entire system lifecycle right from day one.
And the tech complexity backs that up. It's not just building an app. It's integrating reliable frameworks, managing things like cloud SDK quotas, which can kill a startup's budget.
Oh, absolutely. And then you have implementing robust oath patterns, handling metered payment flows with Stripe. It's the full stack, but expanded to include the business logic, the financial side, and the cloud management side. All that experience with audits and scale from the enterprise roles is now setting the foundation for a new product.
Okay, let's zoom out that. Let's look at the 7 years before that, 2017 to 2024. This is the big enterprise period, HSBC Bank and Boeing. This is where that intense focus on automation and cloud scale really solidifies.
Yeah, and these places are heavy on compliance. Everything has to be auditable, repeatable, secure. Look at the HSBC role, lead technical engineer. The focus for 3 years was all about automation, specifically creating JRA stories to automate change, deployment, and security scan and audit processes. So security isn't an afterthought, it's baked into the pipeline.
And the cloud work is supporting banking infrastructure. That's deeply complex. We're seeing R&D for GCP, VPC, Kubernetes, Docker, all provisioned with Terraform and Groovy.
And this is where that deep-seated security mindset really pays off. They were deep into API security, JWT token verification for secure communication between departments. But the detail that really jumps out at me is creating GCP monitoring and alerting, including alerts for secret manager expiry.
Why is that specific detail so critical? What does that tell you?
It tells you everything about production maturity. If you're not automatically monitoring when your production secrets, your database passwords, your API keys are about to expire, your whole system can just fall over without any warning. A lot of teams do that manually. This shows a move to robust, automated security governance. You learn that kind of detail in high-stakes environments.
So let's jump back again to the DevOps role at Boeing. That was just pure, massive-scale Azure.
Oh, yeah. Boeing was all about engineering for resilience. They were building a developer API storefront site. And they used Azure's top-tier stuff to do it. High availability, multi-region capability, using that trifecta of Azure Front Door, API Manager, and Traffic Manager.
That's an architecture designed for, continental scale traffic?
Exactly. It's built to handle huge load and failover across continents without a blip. It's infrastructure as performance art, really.
The pipeline work there is fascinating, too. Implementing Jenkins pipelines for data scientists who are processing FAA data lakes with AI and ML.
Absolutely.
Yeah.
All of that infrastructure dev, test, staging, prod was provisioned with Ansible and Shell, securing secrets with Key Vault. So that time at Boeing, it really connects that deep security foundation, which we're about to get to, with serious CI/CD and multi-region cloud deployment. It's where the DevOps mindset really matured.
Okay, we've covered the modern cloud leadership. Now we have to take a big step back. Back to the turn of the millennium. Segment 3, the foundation. From 1999 to 2015, this is where that security mindset was really forged.
This is the bedrock. This whole period, especially the time at EA, UBC, and Apple, it shows a deep, hands-on focus on security that informs all the later cloud decisions. They weren't just, reading checklists. They were breaking stuff.
The CV shows this consistent suite of security tools being used everywhere. Findbugs, JSLint, XSSME, ZAP, Squall Map, Skipfish, Nessus. It looks like a hacker's toolkit.
It is, but used for defense. These are industry-standard tools for finding vulnerabilities. They weren't waiting for an audit. They were constantly fuzzing and scanning their own code. So, for example, Squall Map tests for SQL injection, ZAP and Nessus are for scanning web apps and networks. This was just daily operational hygiene, which becomes critical later when you're dealing with banking and FAA data.
And look at this detail from Apple in 2008. They created a J2EE servlet for installation validation that could handle 125 requests a second. And crucially, they were porting C code to Java to mimic secure service signing operations.
That is it's low-level cryptographic engineering. Why port C to Java? Because a lot of the original hardcore crypto libraries are written in C. To make sure the Java app behaved exactly like a secure C component, maybe something interacting with hardware, you have to painstakingly translate and validate it. That's a rare skill, bridging low-level code with high-level enterprise systems.
But even before all the web security work, we see something totally different. Embedded systems. That's a huge sideways jump.
And this is so critical for understanding their depth of knowledge. The role at Coronex in 2007, they were writing C code customizations for ASIC-based firmware.
Okay, I need you to unpack that. What is ASIC firmware and why does it matter so much?
Right. So ASIC stands for Application-Specific Integrated Circuit. It's a chip, a piece of hardware designed to do one thing incredibly efficiently, like controlling a network device. Writing firmware for it means you're working right at the boundary of hardware and software. You have almost no memory, no resources. It's a completely different world from JavaScript. That background means that even today, when they're designing a cloud system, they have an instinct for latency, for thread management, for bottlenecks at the lowest possible level.
And then you go back to the absolute beginning, quality assurance at Xert in 1999, developing new ways to automate finding defects and creating an Zax client fuzzer.
A fuzzer. So a fuzzer is a tool that just throws tons of random malformed data at software to see if it breaks. Building one from scratch shows this curiosity for systematically breaking things to make them stronger. And then at Interwoven in the early 2000s, that's the real genesis of DevOps.
The release engineering role, creating automated service packs, cross-compilers for porting code across operating systems that you barely see anymore, Solaris, AIX, alongside Windows and Linux.
That's right, using tools like Perl and Shell and Gmake, which are ancient now, but they were building the concept of infrastructure as code. That early exposure to cross-platform builds is why they can debug a complex Jenkins or Terraform issue decades later at Boeing. They get what a build artifact fundamentally is.
And we can't ignore the education that underpins it all. A Bachelor of Technology in Secure Computer Systems, including a deep dive into covert channels.
That's a great example. A covert channel is a hidden communication path that breaks security policy. Like finding a way to sneak data out of a system by manipulating the timing of when a process runs. Studying that shows a really advanced understanding of system vulnerabilities. Okay. We've seen the foundation, the corporate scale, the startup leadership. Now for segment 4, the technical breadth, the polyglot engineer. I mean, looking at the technical interest section, the scope is it's astonishing.
It's overwhelming if you just read it as a list.
Yeah.
So let's group it into pillars, make it digestible. We're not just looking at someone who uses these tools, we're looking at someone who gets them. From the metal up.
Let's start with the languages and frameworks, the sheer range.
It shows a commitment to using the right tool for the job. You have C and C++ for performance, Java and Spring for big corporate systems, Python, Groovy, Go for scripting and cloud work. And then you see modern stuff like Elm, Swift, and Kotlin for mobile and functional programming. This person can talk about CPU register manipulation 1 minute and Vue.js component state the next. And then there's the multi-cloud architecture mastery. They've hit every major player.
Yep, GCP, AWS, Azure. And it's not just clicking around in the console. It's infrastructure provisioning. Kubernetes, Docker, Terraform, Ansible. Plus, they're just as comfortable with on-prem virtualization like VMware and Proxmox. That multi-cloud fluency is probably the single most valuable enterprise skill today.
And the security pillar here just confirms everything we saw earlier.
It really does. It goes from protocol-level knowledge, PKI, RSA, SAML, Auth, to the defensive tools like Nessus and ZAP. And crucially, they know secure design processes like OWASP and BSEM. So they're not just fixing bugs, they're building security in from the very start.
And finally, what I think is the ultimate niche expertise, and it links right back to those early embedded roles.
Right. We see an explicit interest in modifying drivers, kernel configurations, and programming embedded boards, including SCADA equipment and protocols like DeviceNet, Modbus, and DNP3. That's Industrial Control System Security.
Industrial control systems. Give us some real-world context for that.
Think about the things that run society. Power grids, manufacturing plants, water treatment facilities. That stuff is all controlled by SCADA systems using these protocols. Understanding how to secure them means you're protecting physical operations from digital attacks. It's a whole other world from corporate IT.
And to bring it all home, that theme of continuous learning. They're currently pursuing a Master's of Technology, covering mobile dev with Swift and Kotlin, big data with Tableau, even graphics programming with OpenGL and Unity, 25 years in, and still learning.
Yeah, this deep dive shows pretty unequivocally that real mastery isn't just about knowing the latest tools, your Vue, your Node, your AWS. It requires a deep historical grounding. That ability to lead a startup today is completely reliant on that early experience in security, release management, and C programming.
So the lesson for you, the listener, is that every big career jump we saw, from DevOps to cloud architect to lead engineer, it was fueled by mixing these skills. The build experience from 2001 is directly used in the automation at HSBC in the 2020s. Securing Stripe payments benefits from auditing C code at Apple a decade earlier.
It really is that blend, a foundational security mindset, polyglot programming, and multi-cloud fluency. We've seen mastery across every environment and every kind of role, which I think raises an important question for you to think about. When you face a new technology in your own work, do you prioritize breadth knowing many systems, or do you prioritize depth mastering one framework? And how might blending that foundational security mindset into your thinking influence the designs you create in the future?
Something powerful to think about until our next deep dive. Thanks for joining us.